So in this problem, we need to find the perimeter and area of triangle ABC as exact numbers, then find the measures of all the angles to the nearest degree. This is a good problem because it requires a lot of previous knowledge, and it also incorporates some of the knowledge that we learned in this unit, which was trigonometry. To find the distance, or the perimeter of that triangle, we need to find the distance of all the sides. So we got to use distance formula, but I like to use Pythagorean theorem. So first let's find the length of BC. I see that BC is a straight up and is a vertical line. I don't have to use distance formula or Pythagorean theorem there. I can just count the number of squares that B is to C. So the length there is 6. So I'll write that 6 there. Now I need to find the length of CA. And if you look down below, I have those two triangles kind of separated. So if I need to find the length of C to A, I know that if I go from C to that right angle, which is right here, that is 5. And if I go from that right angle to A, that's also 5, which tells me that that is an isosceles right triangle, and therefore the length of AC is 5 to the square root of 2, 5 times square root of 2. I'm going to do the same thing to AB. I separated that triangle away from the larger triangle. B to that right angle is a unit of 1. And from that black dotted line, that length is 5. And so if I use Pythagorean theorem there, I can see that it's 1 squared plus 5 squared, which is 26. So AB is the square root of 26, and I can't reduce that. So the distance, the perimeter of all of these, you add all these up, which is just 6 plus 5 radical 2 plus the square root of 26. And be careful when you enter that into the my.hrw.com. Make sure you're using those radical signs. Okay, so now we need to find angle measures. Oh, I'm sorry. Let's go back and find the area. The area is easy. Okay, the length of BC was 6. And that black dotted line there is the height of the triangle. Remember, the height and the base have to make a perpendicular line. So the length of that dotted line is 5. Area of that triangle is 1/2 base times height. So the area ends up being 15 square units. Okay, now we can find the measure of these angles. All right, I'm going to start with finding the measure of angle C. Going back to that triangle from before, if I have an isosceles right triangle, I know that those other two angles are 45 degrees. And this is 45 degrees. So I can know that angle C is 45. And now I'm going to find the measure of angle B. And here I'm going to use tangent. So I know that the tangent of B is equal to opposite over adjacent. So it's 5 over 1, which is 5. To find the angle measure, I need to use the inverse tangent of 5 to get, sorry, I'm going to have to back up there, inverse tangent of 5 to get the measure of angle B. And I'm sorry that I'm kind of writing all over the place here. So thank you for trying to keep up. And the inverse tangent of 5 is 78.7 degrees. But we want to round it to the nearest degree, which ends up being 79. Now I can add these two up, subtract it from 180. So 180 minus 45 minus 79, that will give you 56. So there you go. You have the distance. This is the perimeter that I'm circling right here. There's the perimeter. Then the area. Here's the area, kind of tucked away in there. And these are all the measures of the given angles to the nearest degree.